going to focus a lot on today. The two main things we're going to get you familiar with is percentile and z-scores. That's what this first section is focusing on and talking about. So the percentile of a distribution is the value with p% of the observations less than it. So we just said that we're familiar with like standardized test scores, putting you in a certain percentile. So for example, if you're in the 90th percentile, we said that was good because that means that you outperformed 90% of the people who took the test. Or as we said, another way to say it is that you're in the top 10%. So that's the idea of percentile, is percent of observations that are below whatever value we're looking at. So that is percentile. So we've got 25 students that took a statistics test. So we talked about calculating shape and outliers and all that. But here's a stem plot that will give you these values, and we're going to calculate percentiles from these scores. So that is the graph that we're going to be looking at. So refer back to that graph as we ask percentiles for the following students. So a score of 72. The number of people below 72 over the total. So what's the total? How many total people were there? 25. And we want to look at how many scored below a 72. One. Yeah, one. I thought there were more 60s, but there weren't. One. So they scored 1 of 25 is 0.04, so the fourth percentile. So this lets you get more than just a raw number of how you did, but a basis of comparison with everything else in the data. And well, let's hold off on that. Let's go down the list. So give me these other two as well. I'm giving a minute to 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes?
I have a question.
12? Below 80? Okay. Go ahead.
On the test, why I did like better on the lumen score than on the Canvas score.
Yes?
Why?
It's because I curved it by 3 points.
That was nice, thank you.
I tend to give tests on the more difficult side and then curve them. So that's how I tend to do things. This is 48th. Okay, so notice that even the top score, the 93, is not the 100th percentile. We don't have a 100th percentile because we're looking at what percent of people you scored better than, and you can't score better than yourself. So the highest we can have is the 99th percentile. That would be the top of what we could get. But 96th in this case because we don't have enough to get to the 99th percentile. Questions? Okay. Next. Now, using these percentiles, what we can do is create what's called a cumulative relative frequency graph. And this is basically showing the graph of percentiles as we look at more of the data. Okay? So on the x-axis, we have the x values. We're going to have the x values. And on the y-axis, we're going to have the cumulative relative frequency. In other words, the percentiles. So what's happening in this chart, these are the age of the presidents at inauguration. We'll need a new row for whoever wins this election because they're both older. So we'll need a new row. But in this case, we have the cumulative frequency is 2. Then 45 through 49, we have another 7 people there. So our cumulative frequency now is 9. And our cumulative relative frequency is 20.5. So we're at the 20th percentile once we hit the age of 50. 50 to 54, we've got 13. So now we have a cumulative frequency of 22. So when we say cumulative frequency or cumulative relative frequency, then it's a way of saying how many we've got so far. How many we've had so far. And that's what we keep track of. So this graph, which I will show you in a minute, is going to keep increasing or going up until we get to 100%. So that's what it's going to be doing. It's going to be tracking these cumulative frequency values until we get to the largest values. So it can help you very quickly be able to look at where percentiles are on a graph. So 41, 44. Reagan was also up here. He was also old in inauguration, in case you're curious. Since we're in Reagan town. All right. So cumulative relative frequency graph. So here it is displayed. So what this lets you do is it lets you see and get a visual of the percentiles. And so we can see that 55, from 50 to 55, the relative frequency, we calculated it. That was on the last table. And that tells us where relative frequency is. So let's look at using this graph, using this picture. I want you to answer these two questions. Try these two questions. Was Barack Obama, who was inaugurated at age 47, unusually young? So look at where age 47 is for our percentiles. And then estimate and interpret the 65th percentile. So look on your graph of where the 65th percentile is, and then interpret it. Remember what percentile means. So I'll give you a minute or two to do that. As we're thinking about this problem, I want you to, one thing I want you to focus on here, 5-number summary. And the main ones I want to focus on are the median and the quartiles. So the median, I want you to think about this. The median should be at what percentile? In other words, how many of the values should be below the median? By the definition of what the median is, it's the halfway point. So that means that half of the numbers should be below it. So 50%. So the median should be at the 50th percentile. And then the quartiles, remember, split these in half. So where do you think Q1 is? What percentile? Should be at 25th percentile. And then the Q3 is at which percentile? The 75th. So another use of percentiles is that we can use what we know about those percentiles to figure out where the median and the quartiles would have to be. So sometimes you'll be given a distribution or a list or a set of data, and while looking at that graph, you should be able to tell me where the median or the quartiles are. This is especially useful if we have a huge list of data, so that we don't have to spend a whole ton of time entering stuff into the calculator in order to find the median. Because if we have this chart in front of us, then we can figure out where those percentiles are. Okay. So for example, in this graph, you'd be able to figure out where the median and the quartiles are. We'll practice that again on next week. I've got a problem for you to practice with that. Age 47. Age 47 is on the x-axis. Age is on the x-axis. So there's 47. So we look and we see since 47 is around the 10th percentile of the distribution, Obama was relatively young for president inauguration. There we go. 65th percentile. I'll let you write down in just a minute. 65th percentile. Now we look on the y-axis, because that tells me the percentiles, the relative frequency that we're tallying up of what we have so far. So here's 80, so that's 70. So here's 65. 65th percentile is here. That looks like right around 57. So 57 is the 65th percentile. 57. And our interpretation, you should not interpret a percentile. So 65th percentile means 65% of, here comes context to the questions, what are we measuring? 65% of what? Presidents. Were, percentile measures everything below that value, were under, or were younger than 57 years at inauguration. So that's our meaning of percentile. Questions on that so far? So that's percentiles and interpreting percentiles. Okay, I'm going to leave it there for today. And tomorrow, we're going to talk about another way that percentiles often get calculated is using something called z-scores. So tomorrow we're going to talk about z-scores, what those are, and how to calculate them. I got homework for you.